So fatigue life, if we're talking about for validating for bearings, it's broken up into two sections, but one section has two parts. We have the real world, like we just mentioned, but then we also have more of the testing. The testing is done in both theoretical and simulated situations where the environment is like for the testing portion of it is created to mimic that of what's going to be in the real world. So we can get a very good estimate. Usually CCTY's estimate land anywhere from 80 to 90% of what the actual I would say experience or what the part would actually achieve. And that's because the biggest difference is in the real world you have so many parameters that cannot be simulated just because there's so many that you can't put them all into one test. And that's where the real difference is. It's the human error aspect or the unforeseen circumstance that are seen in the real world that heavily change when you're trying to test and see how much a bearing or whatever the part is, seeing how much it could achieve in a theoretical or simulated environment versus the real world. So the real world is almost always going to have a lower number than what's going to be simulated. So if a bearing, let's say just for example, is going to be set to under this load, under this duration, under this heat, with this kind of corrosion, it'll last, let's say, 1 million cycles in the simulated environment. When you go into the real world, it'll maybe be 75 to 85% of that actual number, just because there could be unforeseen circumstances, like maybe somebody is operating the machine in a way that they're not supposed to, or potentially they could be new, they could be under training. So there's a lot of things that you can't simulate all at the same time. So that's kind of the main thing.